Are your eyes sensitive to the light at night?
Do you fumble for light switches when you can't see them?
Light switch.
Oh, my head.
Do your parents or roommates get on your case for leaving the lights on?
Kyle, shut off the darn light! How many times have I told you, waste electricity?
Do you like being lazy?
That was close.
Then you need the automated baseboard lighting system. So what does automated baseboard lighting system mean? Well, it's an intelligent LED strip that's placed just above your baseboards. It's got sensors embedded in it that will intelligently detect motion. So as you walk by, it will light up in front of you and it will dim the LEDs behind you.
Who will use this, you ask? Homeowners, small business owners, elderly people, and vampires.
Well, now where will you use this? You can use it almost anywhere. Mostly indoors, such as in hallways, on the stairs, in your kitchen, bathrooms, basements, or even your crawl space.
When to use this product? Well, when it's dark, or when you want to show off to your friends. Why would you use this, you ask? Because it's efficient, it saves you money, it's easy, and it's a step closer towards complete home automation.
Now, how would you use this? It's simple. You install it, plug it in, and you use a remote control to turn it on.
Some of the customer requirements include emergency lighting capability, the discrete design, a motion detection, different operation modes, remote user interface, and a safe, durable, and efficient product.
The first customer requirement we're going to talk about is the emergency lighting capability. Now this will happen in the case that there's no wall power and the batteries will power the circuit. Batteries will supply 6 hours of emergency lighting, which is usually enough time for the power to come back on by then. One of the requirements we have is there will be at least 48 flux downwards on the ground, which is equivalent to a really bright flashlight in the dark. This allows for a more useful multi-purpose lighting system.
Discrete design is another important customer requirement for our baseboard lighting system. The physical properties of the system will be the LED strip, which will be 4 feet long, 3 inches tall, and will protrude from the wall no more than 1.5 inches. This is important because it will eliminate obstructions in already narrow hallways and small rooms. The control box itself will go on the end of the LED strip, and its size will be no more than 6 inches long, 3 inches tall, and 2 inches from the wall. Inside the LED strip will be 16 small LEDs, which you can see they're quite bright and can go anywhere from 0 to 5,000 millicandels each.
A vital piece of this project is motion detection. Motion is detected through PIR sensors that are spaced evenly over the LED strip, and they'll have a range of at least 6 feet. With these sensors, the lighting system will know exactly where a person is, eliminating wasted energy. This allows for much higher efficiency. The efficiency of the LED strip will be 93% to 98% more efficient than a 60-watt incandescent light bulb.
The automatic baseboard lighting system will have 4 different modes of operation. The first mode is the on mode, where the LED strips will turn completely on. The second mode is the off mode, where the LED strips will turn completely off. The third mode is the automatic day mode, and the fourth mode is the automatic night mode. Both automatic modes will detect motion to light up the LED strips. The differences between the two modes are that the automatic day mode will light up regardless of the ambient light levels, and the automatic night mode will only turn on when the light intensity is below a user set threshold.
The lighting system will be controlled through a remote user interface. This remote control will have a range of up to 30 feet, and it will control the modes of operation for the lighting strip. Another thing that this will control is the brightness of each LED, and it will allow the LEDs to range from 0 to 5,000 millicandels each. Another feature of this lighting system is that one remote user interface can connect to multiple LED strips.
Finally, the automated baseboard lighting will be a safe, durable, and efficient product. It will include a rigid casing for the LED strips so that it can be placed on straight walls, and it will be inflexible with a plus or minus 2 inches from the neutral position over a 4-foot span. It will also include a flexible casing for the corners and edges of walls. For the remainder of fall term, we'll be spending the next 3 weeks finalizing our design implementations and ensuring that it's the specifications that we'd like it to be. Once the design has been completed, we're going to spend the rest of winter break purchasing our parts. When winter term begins, we will spend an estimated 5 weeks on prototyping. Once the prototyping has completed, we'll spend 2 weeks on testing the prototype to ensure that there aren't any flaws or bugs inside. When the testing is completed, we'll begin designing the final implementation, and then we'll spend another week or 2 on testing the final implementation to ensure that everything works out okay. Once we are done with the final implementation, we will spend 2 more weeks for doing our final tests. And then when spring term begins, we will be spending the remainder of the time to finalize our presentation and prepare for the engineering expo.
The block diagram is broken down by function, and this allows for independence of each block. This means that each block can be tested and designed independently. The 4 main functions that we broke this down into are power, control, input-output, and command control. For power functionality, we have our power supply block. For our control functionality, we have the control unit. For the command control functionality, we have our user interface. And finally, for our input-output functionality, we have the LED and sensor strip. And now we're going to talk about the power supply block. Now the first part of this block will have our AC to DC converter, which will take the unregulated wall power, the unregulated AC wall power, and rectify it to output unregulated DC power. This is connected to the voltage regulator, which will regulate the voltage and steady the output. Now coming off of the AC to DC converter, we're going to have our intelligent recharge circuit, which will charge our batteries until they're fully charged, and then turn off once they're fully charged so we do not overcharge the battery and damage them. Now in the voltage regulator, there'll be a current switch that will distinguish whether we're getting wall power or not. In the case that we're not getting wall power, the battery will supply power to the circuit, and we will have regulated DC power going to our control box.
The next 2 blocks that we'll talk about are the LED strip and the control unit. Now on the LED strip itself, we have 2 sensors. One is the PIR sensor, which will detect motion from outside of the strip, and we have a photoresistor to detect the ambient light levels around the strip. Now, the last component we have on the LED strip is the LEDs themselves, which are driven directly by the LED drivers in the control unit. Now, these LED drivers receive their commands from the microcontroller, and this microcontroller is essentially the brains of this whole system. It receives its commands through the firmware code that has been flashed to it, and this code determines the behavior of the microcontroller and the LEDs in response to the input of the sensors. Now, the microcontroller is also linked to the user interface via a Bluetooth connection.
And finally, the last major block in the block diagram is the user interface. The user interface represents the remote control, which runs separately from the other 3 major blocks. Inside of the user interface is an external battery, which supplies voltage to the voltage regulator, which regulates voltage necessary to run the microcontroller that is responsible for handling the code that will transmit to the Bluetooth module the 4 different modes of operation that will operate the LED strips. These 4 modes, depending on whichever one that the user selects, will then be outputted to the LCD display. which will indicate to the user what current mode of operation is being used.
So we've told you what the automated baseboard lighting system is, and we've gone over some of the project requirements.
We've also had a chance to tell you about our rough project timeline so we can tell you when we will plan to finish our project.
We've also gone over the block diagram and each block inside to discuss its purpose and functionality.
Automated baseboard lighting system!